Good morning and a warm welcome to all on the 73rd virtual webinar of Sadgun Sangvi. We continue with our OHSMS series, the Industrial Safety Series. Our topic for today is Indian Boiler Regulation 1950, which has been taken up by Mr. Afzal Hassan. This shall be followed by question and answer session. Let's quickly go through the agenda for the Sadgun Sangvi. Shall be started by the virtual inauguration by Dr. Sundar Kataria. It shall invoke the blessings of deity by chanting of Gayatri Mantra, introduction of the speaker, presentation by Mr. Afzal Hassan, question and answer session, and then we close this session. Sadgun Sangh, conceived and led by Dr. Sundar Kataria, driven with a mission to elevate the quality, safety, and environmental awareness levels of industry. Sadgun Sangh is a series of educative, informative events aiming to illuminate professionals on possible solutions to current issues of industries and economy. A brief introduction of Dr. Sundar Kataria. He is the Chairman and Managing Director at International Certification Services Private Limited. He has completed his Mechanical Engineer AMIE. He is also an honorary doctorate in Business Management. He started his career in building India's first nuclear power plant at Rawat Bhata, Kota, Rajasthan. He contributed in developing India's first oil and gas field at Bombay High since its inception. He was the head of the industry and offshore development with DNV for 2 decades. He is the founder of first. Can we have everyone else muted, please? He is the founder of first Indian Conformity Assessment and Inspection Body known as International Certification Services Private Limited, which is a provider of total quality solution under a single umbrella with wide spectrum of services. He has received Lifetime Achievement Award of NACE Corcon and also received several national and international awards. I now request Dr. Kataria to virtually inaugurate this session.
कल्याणम् आरोग्यं धनसम्पदः शुभं कुरु त्वं कल्याणम् आरोग्यं धनसम्पदः शत्रुबुद्धिविनाशाय दीपज्योतिर्नमोऽस्तुते दीपज्योति कल्याणम् आरोग्यं धनसम्पदः शुभं कुरु त्वं कल्याणम् आरोग्यं धनसम्पदः शत्रुबुद्धिविनाशाय
Please join us for the recitation of Gayatri Mantra. A brief introduction of our keynote speaker, Mr. Afzal Hassan. He is the General Manager, Inspection in International Certification Services Private Limited. He's completed his BTech in Mechanical. He's also an American Society for Non-Destructive Testing Level 3, ultrasonic testing, radiographic testing, magnetic particle testing, penetrant testing, and BARC RT Level 2. His area of specialization includes non-destructive testing, quality control and quality assurance, third-party inspection, welding, and pipeline. Please welcome Mr. Afzal Hassan. Over to you, sir.
Afzal sir, you can start.
Yeah, okay. Yeah, good morning, everybody.
Morning, sir.
Good morning, sir.
Yeah. Slide is visible or not?
Yes, sir, it
Yes,
is
sir.
visible, sir.
Yeah. Welcome in the session of Introduction to the Boiler and Indian Boiler Regulation Act 1950. So before understand the regulation, we have to understand what is boiler. A boiler is an enclosed vessel that provide a means of combustion heat to be transferred into the water until it become heated water or steam. The hot water or steam under the pressure is then usable for transferring the heat to a process. Water is a useful and cheap medium for transferring heat to a process. When water is boiled into steam, its volume increase about 1600 times, producing a force that is almost a explosive gunpowder. As a gunpowder, this caused the boiler to be extremely dangerous equipment that must be treated with utmost care. Function of boiler. Boiler, as a name suggested, is a device equipment to boil the fluid, generally water. Part of boiler, basically when we boil the water, we need a container, or we can say a tank, and source is a water. Fuel for providing the heat. So without fuel or without source of heat, we cannot generate the steam. So different types of fuel we used in the boiler, like a solid fuel, liquid fuel, and gases. When we use the fuel is heated, burn and generate the heat. That heat we use to boil the water, and when the boil the water, the temperature is increases and steam is generated in the container. That steam is produced, that steam we use in the boiler. Main purpose of the boiler is to be heat water and generate the steam. Steam produced can be used in the variety of purposes like power generation, space heating, sterilization and water heating, dyeing and processing of chemical plants. Boiler mountings. Boiler mountings are the set of safety devices installed for the safe operation of boiler. Mounting are integral part of boiler. These are the 7 main mounting on boiler shells are required for the safe operations. One is safety valve, steam stop valve, vent valve, pressure gauge, water level indicator, feed check valve, and fusible plug. These locations of each device is shown in this diagram. Most of the devices are installed on the top of the boilers. Functions of boiler mountings. Device name is safety valve, used for the boiler pressure protection and other applications such as a downstream of pressure reduction control. Although the primary role is for safety, safety valve are also used in the process operation to prevent product damage due to excess pressure. This is the safety valve. This is the steam stop valve. It is fitted over the boiler in the between the steam space and steam supply line. Its function is to regulate the steam supply from the boiler to steam line. Vent valve. The vent valve kept open while starting up the boiler is called the startup vent valve. This valve is useful to vent low pressure, low temperature and pressure moistured steam, as well as the raise steam pressure slowly. Pressure and temperature gauge. Function of pressure gauge is to measure the temperature and pressure of steam inside the boiler. Gauge is usually mounted on the front top of the shell or drum, such that it should be clearly visible to the operator. Water level indicator. Water level indicator inside the boiler vessel. It shows the level in the boiler drum. So we have to maintain the level of water inside the drum so that we can see the water level with the water level indicator. Feed check valves. Feed check valve are one of the most important component of boiler, which control the flow of water from the feed pump to the boiler and further prevent the backflow of water from the boiler to pump when the boiler pressure is more than pump pressure or when the feed pump stop working. Fusible plug. Fusible plug. The function of fusible plug is to protect the boiler from the damage due to overheating of boiler. Tube. By low water level, it is simple. A hollow gunmetal plug is screwed into the firebox crown. Boiler accessories. Boiler accessories are a device that are installed along the boiler and surrounding area to increase the efficiency of the boilers. Most of the accessories are there: superheater, economizer, feed pump, and air preheater. Location of all the accessories are installed according to as per the schematic diagram is given in this slide. Feed pump. Boiler feed pump help to feed the water to steam generator such as a boiler. Boilers are pressurized tank used to heat and vaporize water into the steam. In order to produce the steam, boiler and steam generator required feed water. Economizer. Economizer is a heat exchanger that transfer the heat in the fuel gas to another medium and use for save energy by using the exhaust gases from the boiler to preheat the cold water used for the boiler feed water. This is the photograph of economizer. Superheater. Superheater is a device used to convert the saturated steam or wet steam into the superheated steam or dry the steam. Superheated steam is used in the steam turbine for electricity generation, steam engine, and in the process such as a steam reforming. This superheater is basically installed inside the combustion area to reduce the heat from the saturated heats. Air preheater. Air preheater is a device designed to heat air before another process, for example, combustion in the boiler, with the primary object of increasing the thermal efficiency of the process. Type of boilers. Boilers are categorized in the different manners according to the content in the boiler. Boiler are categorized in two categories. One is called the fire tube boiler, one is called the water tube boilers. Fire tube boiler, in the fire tube boiler, the fire or hot gas is presented inside the tubes and water surrounding these fire tubes. Since fire is inside the tube, and hence it is named as a fire tube boiler. Heat from the hot gases is conducted through the wall of the tube to the water. Example of fire tube boilers are simple vertical boiler, Cochrane boiler, Lancashire boiler, Cornish boiler, locomotive boiler, Scott marine boiler, and Vulcan boiler. These are the example of fire tube boilers. This is the photograph of fire tube boilers. Water tube boiler. In the water tube boiler, the water is present inside the tube and fire or hot gases surrounding these water tube. Example of water tube boiler are Lamont boiler, Benson boiler, Stirling boiler, Babcock and Wilcox boiler, Yarrow boiler, and Leofler boiler. This is the fire tube boiler, and earlier was the water tube boiler. Fire tube boiler versus tube boiler. Fire tube boiler is a boiler in which is the hot flue gases are present inside the tube and the water surrounding this tube. As a fire is present inside the tube, hence it is called the fire tube boiler. Steam produced by this boiler have a pressure of about 25 bar, and that's why they fall under the category of low pressure boiler. The steam generation rate is these boiler are low, 9 tons per hour approximately. For a give power, the floor area required for the steam generation is more, and it is about 8 meters square per ton per hour. The erection and transportation of these boilers are not easy, and this is because of this part cannot be separated. If we talk about the efficiency, then overall efficiency of fire tube boiler is about 75%. Operating cost of this boiler is low. It is not suitable for the large power plant but used in the small power plant. Fire water tube boiler. It is a boiler in which the water is present inside the tube and the hot flue gases surrounds the tube. Since the water is present inside the tube, hence these boilers are called the water tube boiler. High pressure steam is produced by these boilers the pressure of the steam is about 165 bar. These boilers fall under the category of high pressure boiler. The steam generation rate in the water tube boiler is high, that is about 450 ton per hour, which is more than water tube boiler. For a given power, the floor area required for the generation of steam in this boiler is less 5 meter square per ton per hour. So that is very small area is required, high pressure is generated and used for the very high power generation, these boilers. Erection and transportation is easy as it is a part can be separated. Overall efficiency of water tube boiler with economizer is about 90%. The operating cost is high, suitable for the large power plant. Type of boiler according to the number of tubes. According to the number of tubes, the boiler are classified as a single tube boiler and multi-tubular boiler. Single tube boiler, which contain one fire tube or water tube, are called as a single tube boiler. Example of single tube boiler as Cornish boiler and simple vertical boiler. Multi-tubular boiler, which have 2 or more water tube or fire tube, are called the multi-tubular boiler. Example of multi-tubular boilers are Lancashire boiler, locomotive boiler, Cochrane boiler, and Babcock and Wilcox boilers. According to the position of furnace. According to the position of furnace, the steam boiler are classified as an internal fired boiler and external fired boiler. Internal fired boiler, in which the furnace is located inside the boiler shell and are called the internally fired boiler. Among all the fire tube boiler, most of the boiler are internally fired boilers. External fire boilers. In the externally fired boilers, furnace is located outside the boiler shell. In this furnace is arranged underneath brick work setting. Water tube boiler are always externally fired boiler. According to the axis of shell. According to the axis of shell, the boilers are classified as a vertical boiler and horizontal boiler. Vertical boilers, the boiler in which the axis of shell is vertical are called the vertical boiler. Examples of vertical boilers are simple vertical boiler and Cochrane boilers. According to the shell, horizontal boiler, when the axis of shell in a boiler is found horizontal, then it is called the horizontal boiler. Example of horizontal boiler are Lancashire boiler, Babcock and Wilcox boiler, and locomotive boilers. According to the method of circulation of water and steam, the steam boiler are divided into the natural circulation boiler and forced circulation boiler. Natural circulation boiler, circulation of water take place naturally by convection current that set up during the heating of water. In the most of the boiler, there is a natural circulation of water such as a Lancashire boiler and Cochrane boiler, etc. Forced circulation boiler. In this type of steam boiler, the water circulation takes place with the help of circulation pump driven by some external power. Here the circulation is forced by some external agency. Forced circulation is used in the high pressure boilers such as a Lamont boiler, Lowy Fuller boiler, and Benson boilers. According to the use. According to the use, boiler are classified boiler and fixed boiler, stationary boiler, and mobile boiler. Stationary boilers are the boiler that are stationary and cannot move from one place to another place. Once they are installed, they cannot be transported to the other destination. Boiler are used in power plant and in the industrial process. Mobile boiler, these are the steam boiler that cannot be moved from one place to another place. Mobile boiler can be used for the one place to another place. Locomotive and marine boiler are the mobile boiler. This is the schematic diagram of power generation. Use the boiler. Boiler, generally the power station is installed at the very close location where the water is available and the source of heating is available, like a fuel and a solid fuel. Different, the requirement of fuel and water is important. Then the power generation plant can be installed. This is the schematic diagram for heating the space. History of Indian boiler regulations. Steam boiler are very ancient origin. The introduction of famous James Watt improved the steam engine from 1769 to 1775 onward, resulting in the great improvement in the steam plants. In the year of 1863, a very serious boiler explosion occurred in the Calcutta, which caused the loss of several lives. As a result of these explosions, necessity of inspection boiler was widely recognized and bill was introduced in the Bengal Council to provide for inspection of a steam boiler. In the year 1864, the Bengal Act 6 of 1864 was passed, which provide for the inspection of a steam boiler and prime movers in the town and suburbs of Calcutta. This is the beginning of boiler legislation in India. Central government appointed the committee called the Boiler Law Committee in 1920 to examine and report on the general question of boiler legislation in India. Committee prepared a draft act on this line, of which the Basic All India Act was passed in 1923. The Boiler Law Committee also prepared a uniform set of technical regulations and the model set of administrative rules. A sharp distinction was drawn between the regulation and the rules. Regulation referred entirely to the technical matter, whereas the rule referred to the questions concerned to the administration of the act. Indian Boiler Act 1923 was enacted with the objective to provide mainly for safety of life and property of person from danger of explosion of steam boilers and for achieving the uniform in registration and inspection during operation and maintenance of boiler in India. Governments of India Act 1935 assigned the subject boiler to concurrent field. The provision for constituting Central Boiler Board having the authority to make the regulation consistent with the act was made in the Indian Boiler Amended Act in 1937. A board called the Central Boiler Board was accordingly constituted in the year of 1937, constituted in the 1937. CBB, Central Boiler Board. Central Boiler Board, in exercise of the power conferred under the Section 28 of the said Act, formulated regulation on boiler. The current version of these regulation is known as the Indian Boiler Regulation 1950. With amendment, Central Boiler Board is responsible for making the regulation of laying down a standard of boiler for material, design, constructions, registration, inspections. Indian Boiler Regulation are standard. IBR, Indian Boiler 1950, Indian Boiler Regulation are standard for boiler and boiler component for compliance of IBR by the manufacturers and users of boiler in the country in the respect of material, design and construction, operation and maintenance, inspection, testing, certification during manufacturing or operation and maintenance. Chapter-wise content in IBR 1950. Chapter 1 is talks about the regulations. Chapter 2, electric resistance welded steel boiler and superheat heater tubes for design metal temperature not exceeding 454 degrees centigrade. Chapter 3 is talks about the boiler tube subject to the external pressure. Chapter 4, regulation for determining the working pressure to be allowed on various parts of boiler other than the fusion welded and seamless forged drum. Chapter 5, fusion welded and seamless forged drum for water tube boiler and superheater. Chapter 6, requisite mounting and fitting and auxiliaries. Or Chapter 7, boiler and superheater tube, heaters and other pressure part tubes. Chapter 8, the steam pipes and fittings. Chapter 9, regulation for registration of boiler and inspection of boiler and steam pipe. Chapter 9A, safety of persons inside the boiler. Chapter 10, electrode boiler, general requirements. And Chapter 11, standard condition for the design and construction of economizer, feed pipes, feed heater, and other similar vessels. Chapter 12, shell type boiler of welded construction. Chapter 13, qualification test for welder engaged in the welding of boiler and steam pipe under construction, erection, and fabrication at site in the India and in repairing boiler and steam pipe by welding. Chapter 14, regulation made under the clause AA of section 28 of the Act, small industrial boiler. Chapter 15, feed water for boiler, and last one is appendix. Chapter wise content, and this is the regulation wise content in 1950. Total regulation in the IBR 1950 is 626, and last amendment was done in 2022. Numbers of amendment are done in the IBR 1950. Important definitions in these regulation, unless the context otherwise required in these regulation, unless the context otherwise required. Act means the Indian Boiler Act 1923. Accident means an explosion of the boiler and steam pipe or any damage of boiler or steam pipe which is calculated to weaken in the strain thereof as a render it liable to explode. Boiler means any closed vessel exceeding 22.75 liter in the capacity, which is used expressly for generating the steam under pressure and includes any mounting or other fitting attached to such vessel which is wholly or partly under the pressure when steam is shut off. Calculation of pressure in the relation to the boiler means the design pressure of any part adjusted to take into the account the pressure drop corresponding to the most severe condition of pressure drop and hydraulic heads. Chief inspector, inspector means respectively a person appointed to be chief inspector and inspector under the act. Competent authority mean an authority recognized by the Central Boiler Board in the manner as laid down in the regulation 4A to 4H, a competent to issue the certificate to welder for purpose of regulations. Design pressure means relation to the natural or assisted circulation boiler, maximum allowable working pressure in the steam drum of the boiler. In the relation to a once through the forced circular boiler, maximum allowable working pressure at the final superheater steam outlet. Inspecting authority means an authority recognizing by the Central Boiler Board in the manner laid down the regulation 4A to 4H, a competent to grant a certificate from 2 to A or to B. Boiler or steam lines come under the IBR regulation requirement. As per the IBR 1950 and latest amendment Act Amendment 1922, boiler means any closed vessel exceeding 22.75 liter in capacity which is used expressly for generating the steam under the pressure and include any mounting or other fitting attached to such vessel which is wholly or partly under the pressure when steam is shut off. Steam lines having a design pressure, maximum working pressure above the 3.5 kg per centimeter square from the atmospheric pressure. Steam line size above 10 inch inside the diameter having a design pressure 1 kg per centimeter square from the above the atmospheric pressure. So these are the requirement as per the IBR. Boiler and steam lines come under the IBR regulations. Standard requirement for the material, construction, inspecting authorities, certificates, and makers stamps. Material required for the boiler construction. Main elements of the boiler required forming the shell of the boiler is a plate. All plate, rivets, bars used in the construction of boiler shall be tested and found to conform with the regulation herein after the content. Construction, all the boiler during the construction shall be under the supervision of an inspecting officer and shall be inspected at all stage of construction prescribed in the Appendix J of 1950. Tube and steam pipes shall also inspected at the maker's work at the stage prescribed in the Appendix J. And the test conducted by the maker shall also be witnessed by the inspecting authority. Welder engaged in side welding of boiler, steam pipe, economizer, superheater shall possess the produce to the satisfaction of the chief inspector welder performance qualification certificate issued by the competent authority. A certificate in the form of 2 form is suggested by the IBR from an inspecting authority certifying that is the material was tested and the boiler was built under their supervision. Together with With such certificate, inspecting authority may furnish a memorandum of inspection books, Form 1, prepared in the manner prescribed by the Regulation 386 in respect of inspection of boiler during construction, and the hydraulic test applied on completion. In case of boiler which is to be assembled only at site, requirement of hydraulic test on completely assembled boiler by inspecting authority shall not apply provided that the individual part of such boiler have been hydraulically tested and certified by the inspecting authority separately as required under these regulations. For tube and pipe subjected to the internal pressure, a certificate giving results of test regarding the chemical analysis, warm yield 0.2% of proof stress, average stress of produce and elongation of 1% creep in 1 lakh hours, and the average and the lowest stress of produce rupture in 1 lakh hours in the material where the applicable shall be furnished. To number of thousands hour creep rupture test shall be carried out at the temperature of 50 degree above the service temperature for each grade of steel for tubing, piping or casting of plate grades when in the furnace or in the superheater zone. Certification requirement: certificate for a steam pipe, a certificate of manufacture and test is Form 3A signed by the maker and the inspecting authority shall be furnished. Certificate for tube, a certificate of manufacturer and test in the Form 3B signed by the maker and inspecting authority shall be furnished. Certificates for mounting and fittings, a certificate of mounting of a manufacturer and test in the Form 3C signed by the maker and the inspecting authority in respect of the boiler mounting and steam pipe fittings during manufacture shall be furnished. These forms are designed by the IBR. Material of construction: steel or for plate shall be made by the open hearth, electric furnace or basic oxygen process or any other process with give the steel having a equivalent specified properties. Plate for carbon steel shall conform to one of the following 4 grades of tensile strength: 37 to 45 kg per kilogram force per mm square. These are the 4 categories of tensile strength. As per the IBR, the plate classification of plates are categorized in 4 categories based on the range of tensile strength of the steel plates. The steel shall not contain more than 0.05% of sulfur or phosphorus. For the band test of plate of all grades of steel, test piece shall withstand without fracture, being band cold through the 180 degree around a mandrel, a radius of which shall have a relationship to the plate thickness as given below. Tensile strength and mandrel radius: if the tensile strength is the range between 36 to 49 kg per mm square, the mandrel size should be 1 T and no fracture on the surface. And the 41 to 57, the same mandrel size is required. 45 to 64 kg per mm square if the tensile is strain, then the mandrel radius should be 1.5 T, where T is the plate thickness. Edge of the all plate and butt sharp shall be machine or flame cut by machine. All edge shall be beveled and angle not sharper than 70 degree to the plane of the plate and between the 70 to 80 degree where the practicable. Plate which are to be flame cut by machine without heat treatment or subsequent grinding machining shall not have a carbon content higher than the 0.26%. Where the carbon content exceed to 6% heat treatment, grinding or machining shall be carried out. No boiler plate shall be less than 1/4 inch in the thickness used in the boiler according to the IBR regulations. Design requirement as per the IBR, factor of safety shall be in no case be less than 4. However, as per ASME boiler pressure vessel code, International Boiler Pressure Vessel Code, Section 8, Division 1, the factor of safety requirement is 3.5 for the non-bolting or 4 to 5 for bolting material. It means the IBR more stringent than the international ASME code, Section 8. Every boiler shall be provided at least with the following: 2 safety valve, one of which may be high steam and low water type safety valve. In no case should the bore of the seat of the valve be less than 19 mm. 2 means of indicating the water level: a steam pressure gauge, a steam stop valve, feed check valve, 1 feed apparatus, a blow down cock or valve, visible plug, and attachment of inspector's test gauge. Attachment of gauges which is required for pressure measurement. Testing requirements. 1. On the component before assemble, cast iron tube, heaters and bands, hydraulic test pressure in lbs per square inch is twice working pressure. Minimum pressure is 700. Steel tube and bands 500 if the design pressure is less than 500 or less, then the hydraulic test pressure should be 1000 lbs per square inch. Above 500 but not exceeding the 1000, twice the working pressure. If the design pressure is above 1000, the 1000 above the working pressure, the hydraulic test pressure should be the 1000 above the 1000 working pressure. Headers, if the design pressure is below the 1000, twice the working pressure, test pressure should be the twice. And if the design pressure is 1000 lbs per square inch, the working pressure plus 1000 test pressure should be the working pressure plus 1000 lbs per square inch. Testing requirements as per the IBR, for all the assembled section, the hydraulic test pressure shall be not less than 1.5 times the working pressure. Working pressure shall be highest pressure at which the economizer relief valve are to be set. Above the test pressure shall be held for the minimum period of 10 minutes. As per the ASME Section 8, Division 1, the test pressure should be minimum 30 minutes. I think it is mistakes. So it is the test pressure for the assembled component minimum requirement is 30 minutes. As per the ASME Section 8, Division 1, test pressure not less than 1.3 times of the maximum allowable working pressure of vessel. It means it is more stringent. IBR regulation is more stringent for testing requirement, which is the 1.5 times required of the maximum allowable working pressure. Requirement of certified welder. No welder shall be engaged on welding of boiler or steam pipe under the construction, erection, fabrication, at site or the repair of the boiler or steam pipe unless they possess the certificate as required under the regulation hereinafter contained. Initial qualification test and issue of certificate. Every welder shall be duly tested, qualified to the satisfaction of the competent authority, who shall assess his performance for qualification for the certificate. The competent authority may be Thereafter, issue a certificate in the form of 13, indicating the class and type of welding in which he has qualified. A certificate issued to the welder under this regulation shall remain valid for the maximum period of 24 months from the date of issue, provided that the holder there has a subsequent to the test been employed with the reasonable continuity on the class and type of work for which he is qualified. Revalidation of certification. The certificate may be extended for the time to time for the period not exceeding 24 months at a time on the completion of requalification test to the satisfaction of the competent authority. A welder qualified for type and process of higher grade of steel can be allowed to weld with the lower grade of steel. Validity of certificate. A welder shall appear for requalification test consequent upon any of the following condition, namely an omissions of backing strip in the arc welding, single welded butt joint, or addition of the backing strip in the gas welding, change in the class of electrode, change in the base material to be welded. If during the preceding 3 months or more the welder has not been engaged in the welding of the type or class for which he is qualified. If there is some specific reason to question her welder's ability, a change from one welding process to any other process, a change from direct current to alternating current, and vice versa. These are the essential variables when the welder requalification. Awarding of marks. Marks shall be awarded in accordance with the Form 12. Candidates obtain the mark not less than 60% in the oral or written exam and not less than the 75% in the practical test. Shall be deemed to have a qualified for the certificate provided that the band tests are found to be satisfactory. Should a candidate fail in the oral and written exam but pass in the practical test, he may be re-examined in oral and written examination within a period of 12 weeks from the date of examination of practical test. And if the obtaining not less than 60% marks in re-examination, he shall be deemed to have qualified for the certificate. Form shall be attested by the competent authority and filled in this office for future reference. Basically, as per the ASME section 9, only the practical exam, practical test or demonstration is required to perform the welding on the pressure vessel component. As per the IBR, written or additionally written and oral exam also required. It means the welder who is IBR qualified is more competent. He knows the theory and materials and essential requirements compared to qualified as per ASME section 9. Penalties for the illegal use of boilers. Any owners of boiler who in any cases in which a certificate of provisional order is required for the use of the boiler under this act, uses the boiler either without any such certificate or order being enforced at the higher pressure than that allowed to hereby a small punishable with fine which may extend to the 500 rupees, and in the case of continuing offense with an additional fine which may be extended to 100 rupees for each day after the first day in the regards to which he is convicted for the having the persisted in the offense. Classification of boilers. As per IBR, classification of boiler as per IBR in the 4 class, special class that is applicable for any boilers, Class 1, 2, 3. Class 1 is boiler pressure is up to 125 kg per centimeter square. Class 2 for the boiler pressure up to 40 kg per centimeter square. And class 3 for the boiler pressure up to 17.5 kg per centimeter square. Hydraulic and hammer test. Class 1 boiler. Each class 1 boiler shall, on the completion of all the welding repairs after heat treatment, be subjected to the hydraulic test of 1.5 times the design pressure without any indication of appearance of defect. Class 2 and class 3 boiler. Each class 2 and class 3 boiler shall be tested to a pressure twice the design pressure. Test shall be witnessed by the inspecting authority or inspecting officer. Test pressure shall be maintained for the period not less than 30 minutes. It is important in the interest of safety that the boiler be properly vented so as to prevent formation of air pocket before the test pressure is applied. Inspection fee for the wall and flanges to be paid by the manufacturer to the IBR, subject to the minimum inspection fee for 600 rupees per inspection. The fee for inspection of wall shall be charged as under: up to 25 mm, rupees 15 per piece; above the 25 mm up to 100 mm, rupees 45 per piece; and 100 to 250 mm, 270 rupees per piece; and 250 mm to 720 above the 250 mm diameter of wall, 720 rupees per piece. Fee for inspecting of flange shall be charged as under: for charge for the forge and cast fitting up to and including 25 mm for the batch of 50, part therefore to 25 rupees, up to 25 to 100, that 390 rupees per batch, and over the 25 mm up to including 50 mm batch of 50 or thereafter rupees 435. Over 50 mm up to including 100 mm for the batch of 25 or part thereafter thereof 435 rupees. Over the 100 mm and including 250 mm for the batch of 10 or part thereof rupees 465. Over the 250 mm for the batch of 5 or part thereof rupees 540. For the plate flanges, these fees shall be charged half of the rate charged for the forged and cast flanges. So this is the charges, and registration charge also different based on the area of exchanger, area of boilers. Procedure for recognizing the competent persons for inspection and certification of boilers. Minimum qualification and experience must be graduated in the mechanical, production, power plant or metallurgical engineering from the recognizing institutions. Minimum 5-year post-qualification experience, single or cumulatively in the following field related to the boilers: design, manufacturing, commissioning, operation and maintenance, inspection and certification during manufacturing and operation and maintenance. High pressure welding inspection must be the level 2 NDT certified from ISNT or ASNT in RT and UT. Central Boiler Board examination process, because the competent this exam is conducted by the CBB. Process of CBB for examination: routine exam consisting of design, manufacturing, operation, maintenance of boiler, non-destructive testing technique, inspection and certification of boiler during the manufacture and use as per the Indian boiler regulation. VIVAS on the above 30% weightage shall be given for the VIVAS. The Central Boiler Board shall will issue a passing grade certificate to the candidate after passing the examination. Candidate shall secure at least 60% marks in the routine examination. Minimum 45% marks shall be required to each paper with the aggregated of minimum 60 in 2 papers. as well as the was in order to pass the examination. Worst boiler accident, SS Sultana in Helena, Arkansas, April 26, 1865. 1,800 people died on the ships because of the failure of boiler. Boiler blast at a power plant, NTPC, Raebareli, date 1/11/2017. An explosion at a coal-fired power plant. In the power plant, NTPC Raebareli has killed 16 people and injured around 80. The blast reportedly occurred when a pipe in newly installed boiler burst and spewing hot ash on workers. Boiler explosion at Lucknow Chemical Factory, 20 June 2020. A labor was killed and 2 women workers were injured when a boiler exploded at the chemical factory in Chinat at Lucknow. One more boiler explosion at the Newly Lignite Corporation, Tamil Nadu. Explosion done at the 1st July 2020. The mishap occurred at the 5th unit of thermal power station 2 when the workers were in the process of resuming operation, which includes maintenance work following a shutdown. 6 people died on the spot, while the 17 others were injured due to the explosion. Boiler explosion at thermal power plant in Sonbhadra, April 4, 2021. 13 labor were injured following an explosion in a boiler in the Lanco and Para thermal power plant. Boiler explosion at Bihar, Muzaffarpur, 26 December 2021. 6 labor were killed and more than a dozen were injured after a boiler exploded in the noodle making factory in Bihar, Muzaffarpur. Boiler blast in Tamil Nadu, 1st Feb 2022. 2 migrant workers were killed on the spot, while 3 others sustained injured in the boiler explosion at the Bismi Fisheries Private Limited at Tamil Nadu. Pressure cooker is just like a boiler, but it is a very small quantity. When it is explode, it create a lot of heat and steam. It is a very dangerous equipment we use safely. 11 September 2021 or 2011, 8% were injured in a pressure cooker blast at a canteen near the compound of Tata Motor Private Limited. 9 February 2018, a female midday meal worker suffered burn injuries on her arms and face after the pressure cooker blast in the MDM kitchen. Government Model Senior Secondary School, Sector 44, Chandigarh. What are the safety measures needed when the steaming foods? Stand to the side when opening the steamer, steam jacket, kettle, oven, or other source of steam or hot air. Never reach over a pot or piece of equipment that is vigorously steaming. Wear moisture resistance, heat proof gloves, and use long utensil to the handle or rearrange the food inside the equipment. Type of hazards in steams. High pressure steam can cause the severe burn to the plant, personnel, or even fatalities. High pressure steam leak are typically invisible to the human eye, but are very noisy. Consequently, presence of pinhole leak in the pipe or fitting in a noisy environment. Thank you. Any question?
Thank you, Afzalji, for sharing your knowledge and explaining the topic. I now request the participants to please unmute themselves and ask any questions to him. Anyone has questions, please unmute yourself or put it in the chat box, please.
Use of boiler, Mr. Nikhil Gupta asked. Use of boiler. Boiler is used in the different industries. Basically, most of the industries use the boiler for power generation, for the processing plant, for the textile industries and food industries, and in the hospitals. Different the boiler depend upon the size and use of size of the boiler. Then we use the even boiler pressure. You can say ki the pressure cooker we use in the, it is just like a boiler. That's why I last and the end of the session we have given the example that boiler is a very dangerous because steam is a lot of power and lot of power generate by heating. So we have to take care while we use the handle the steam basically. तो बॉयलर के बहुत ज्यादा यूज है, नॉट ओनली ए सिंगल, मोस्ट ऑफ द इंडस्ट्रीज यूज, इवन छोटे छोटे जो स्मॉल इंडस्ट्रीज हैं वो बॉयलर का यूज करते हैं, बट दैट्स व्हाई बिकॉज इट इज अ वेरी डेंजरस. तो गवर्नमेंट्स ऑफ इंडिया मेक ए एक्ट and regulations and every users according to the size we have already discussed. अगर the कोई पोर्ट जिसमें हम बॉइल करते हैं और बॉइल का साइज इज मोर देन 22.75 लीटर and generate the steam, it is come under the IBR regulations. So you cannot use the such port which you use for generate the steam or the size is more than 22.75 liter. 22 लीटर 22.5 लीटर कोई बहुत बड़ा वॉल्यूम नहीं है, बट उसके जनरेट होने से कितना बड़ा इंपैक्ट आएगा वो बॉयलर मतलब स्टीम से, बेस्ड ऑन दैट IBR एक्ट IBR एक्ट 1923 is make a rule के भाई पहले it was a 25 liter, now it is reduced, is a 22.75. So based on the volume of water used and the pressure, if the कोई pipe है जिसका हम use कर रहे हैं जिसमें steam transport करना है, if the pressure is 3.5 kg or more, then that pipe is come under the IBR regulation. If the pipe diameter is more than equal or more than 10 inch and the pressure is 1 kg per centimeter square, then that pipe also come under the IBR regulation. ISO auditor what to be verified in the time of audit. So basically at the time of audit, IBR auditor should verify these the regulate that the requirements, most of the boilers without approval from the IBR and competent authority, he must have a valid certificate and he must do the maintenance of the boiler at the time, at the schedule given in their as per the IBR guidelines, and the fittings and equipment, जो भी safety equipments वगैरह use किए गए हैं, तो वो at the time of regularly monitor होने चाहिए. And during operation, the range pressure and temperatures should be within the range. And if it is the automation system, so that should be validated. So number of checkpoints are there, but as an auditor, you have to verify the operation and maintenance records and certificate and IBR approvals. Boiler safety standard introduced to the control the accident. Basically, IBR have given a lot of information, what is a lot of requirements to control the incident, because it should be automated. No one manually should not be handle the these operation. So most of the requirement based on the size and capacity of the boiler, IBR have suggested a lot of automation systems that is mandatory as per the requirement. What is what is the generic difference between IBR and 510 and same code in the pressure? IBR and 510 is applicable for the certification of pressure vessels in the during operation and maintenance. IBR is applicable for the design, start from the design, manufacturing, and up to the operation and maintenance. And the IBR is more stringent than API 510. Or API is an international code which is American Petroleum Institute, and same is applicable, but IBR is the mandatory requirement in India. If your if your boiler is not certified from the IBR and maybe certified API 10, but it is a mandatory requirement, it must be certified from the IBR. Any questions?
So, Afzal ji, I have something to add on to what Jayashankar ji asked. So, as an auditor, how much would an auditor have information in terms of understanding IBR or the regulation? Is there some kind of a nameplate or a plate or a display that is placed on the boiler from which you can pick up the cue and then follow your trail of simple questions? Because to most people, understanding a lot of intricacies is difficult from a generic standpoint. So एक basic checkpoint की कि plate पे पहले तो let's get this कि उसके display plate पे क्या क्या होता है?
Yes, display plate basically IBR has given some requirement that display plate should be like a manufacturer name or uska number is given, because each and every equipment is marked from the IBR, given by the IBR कि इसका ये number होना चाहिए क्योंकि it is listed in their record. And again pressure rating, again the production rate के कितना इसका rate है per hour per that information, manufacturer and the last inspection done and the next schedule, the information is recorded on the nameplate.
So basically I can, as an auditor, even if I have to read it, I would understand that there is a number which is issued by IBR. So I know that it is controlled. So this vessel is not some vessel which is just made and put there. So it has been checked once. That is one. Understanding the second point, I will know what pressure rating it will operate at. Do we also have something which is marked as next calibration due or next pressure test due as written on the plate, or it is not a mandatory requirement?
Pressure testing also mentioned because the entire equipment, but other accessories has a different requirement, but the entire pressure
for the boiler, I will also understand that last pressure test done on and the next pressure due on.
Right.
So typically, is it a 5-year period or a 3-year period or a yearly period for pressure tests? Typically.
I think it is a yearly period of inspection and pressure testing. I think not exactly मुझे याद नहीं है कितना है, but it is mentioned in the regulation.
So visual checks will be done on a year and maybe 3-year pattern में once in 3 years they will have to pressure test it to check for its continual suitability. So from an auditor's perspective, we can check the pressure rating, what is the operating pressure, what is the operating temperature, when was it last tested, and we can check the test certificates and check the last pressure rating and the current, whether it is due and done or not due or not done, and whether it is operating outside its range or lower than its range. Would that be correct from auditor standpoint to check?
Right.
Perfect. Thank you so much. Thank you.
Sir, I
Abdul
would
ji.
like here something on this point also. Hello.
Please, Surendraji, please.
Sir, the one more checkpoint is also in this boiler operation is that a person should be competent also from the IBR. Simple person cannot. So personal certification is also you can say one checkpoint, means person should have some certification from the IBR side, sir.
So are you mentioning that to operate a boiler, we will have to have a competent person within the factory who is going to operate the boiler? Is that what you're trying to say? Or a competent person to check it according to its periodicity? Is that
No,
what you're
sir.
saying?
A boiler operator who are operating this boiler inside this premises, he should have some certification from the IBR side. He must have some IBR certification. This is a one checkpoint, and this is a drawback in industry, because we see in industry that ordinary person or the person who are, you can say, from the organization side just operate without any certification.
Correct,
So
correct.
this is a one drawback in industry.
Absolutely. What you're saying is absolutely right. And that is why these knowledge sessions help us in understanding, because ISO typically talks about meeting all kinds of statutory and regulatory requirements, and all our auditors make a checkbox. But in such a big plant, there are so many statutes and regulatory requirements for each equipment. So it is very difficult for an auditor to have that kind of knowledge or information. And these sessions help us to understand the kind of knowledge. So thanks for sharing that. I think और कोई कुछ बोल रहा था, खन्ना जी बोल रहे थे या शंकर जी बोल रहे थे? Someone was saying something.
मैं बोल रहा था सर, खन्ना बोल रहा
Please, sir.
हाँ, गुड मॉर्निंग सर। अच्छा सर, मैं जानना चाहता हूँ कि देखिए, जो बॉयलर की हम बात कर रहे हैं, हमारे पास इंडस्ट्रियल हीटर्स होते हैं, बड़े बड़े होटल्स में बड़े बड़े वाटर हीटर्स लगे होते हैं, है ना? तो इन सब में बॉयलर्स में क्या बेसिक डिफरेंस होता है?
सर बेसिकली बॉयलर में जो आईबीआर के अंडर में आते हैं, बॉयलर तो वही है जो आपको बॉयल करके स्टीम जनरेट कर रहा है। इट में भी जैसे प्रेशर कुकर है, वो भी एक बॉयलर ही है, राइट? बट द साइज ऑफ जो आईबीआर जो रेगुलेटरी बोर्ड मतलब एक्ट के अंदर आता है, वो है बेस्ड ऑन साइज. इफ द वॉल्यूम ऑफ वाटर या कंटेनर इज 22.75 इज ग्रेटर, जिसको आप कंटेनर को गर्म करके स्टीम जनरेट करा रहे हैं, ओके, उसका साइज अगर इससे बड़ा है तो वो आईबीआर के अंदर आ जाता है. इट मींस उसका सर्टिफिकेशन मस्ट है.
राइट सर, नोटेड सर.
और दूसरा, अगर वो हो सकता है उससे छोटा भी हो, बट उसमें आप प्रेशर 3.5 kg से ज्यादा जनरेट, स्टीम का प्रेशर इज मोर देन 3.5 kg जो ट्यूब्स आप यूज करते हो. मतलब ये तो एक कंटेनर के साइज के हिसाब से हो गया, लेकिन कंटेनर इट में भी सेम, और बट इसकी जो एक्सेसरीज है उसमें आप प्रेशर 3.5 kg से ज्यादा यूज कर रहे हो, जो पाइपिंग यूज कर रहे हो, दैट पाइपिंग should be come under the basically is a fall under the regulation requirement. और पाइप का डायमीटर अगर 10 इंच से ज्यादा है, 10 इंच या उससे ज्यादा है, और 1 kg का वो स्टीम कैरी करता है, तो वो भी आईबीआर रेगुलेशन में आ जाता है. तो ये 3 कैटेगरी डिफाइन की गई है आईबीआर में कि क्या आईबीआर में आता है सर्टिफिकेशन के लिए और क्या नहीं आता.
राइट, थैंक यू सर.
Afzal ji, I have one doubt. Afzal ji.
हाँ बोलिए.
Apart from the boiler pipeline also come under the routine inspections, because the pipeline are having also the pressurized streams, so it come under also the inspection.
Yes, the same, because that's why they have boiler, and boiler के जो पाइपिंग का diameter जो उन्होंने define किया है, if the diameter or pressure come under this the requirement, then these are come under the inspection.
But generally we do not see this type of, you can say, routine inspection during the audits or during the, you can say, inspection. Generally, organization does not cover this pipeline under the routine inspection.
पाइपलाइन मतलब अगर उसका प्रेशर, मैं वही बता रहा हूँ ना, पाइपलाइन का साइज 10 इंच से ज्यादा है, 10 इंच या उससे ज्यादा है, और उसके अंदर स्टीम का प्रेशर 1 kg या उससे ज्यादा है, then it's come under the IBR. Clear?
Okay, fine.
Pipe का diameter is less than 10 inch and the pressure is more than 3.5 kg, then it is come under the IBR. So these two conditions are there.
अफजल जी एक क्वेश्चन है।
हाँ जी,
हाँ अफजल, ये जो अभी सेफ्टी पॉइंट ऑफ व्यू, बॉयलर के सेफ्टी पॉइंट ऑफ व्यू, उसका फीड, उसका प्रेशर, टेम्परेचर, ये सब मायने रखता है, तो उसके लिए क्या स्टैट्यूटरी या रेगुलर, मतलब ये एक्ट या रूल में ऐसा कोई प्रोविजन दिया हुआ है क्या कि इसमें ये ऑटोमेशन भी होना चाहिए, या फिर इस तरह से ऑटो कंट्रोल या इंटरलॉकिंग सिस्टम होना चाहिए, ऐसा कोई रिक्वायरमेंट दिया हुआ है क्या?
यस, रेगुलेशन में रिक्वायरमेंट दिया है, इन ऑटोमेशन का भी रिक्वायरमेंट है, और मिनिमम जो एसेसरीज एंड फिटिंग्स एंड सेफ्टी डिवाइसेस इज रिक्वायर्ड, दे हैव डिफाइन कि ये होना चाहिए। अगर कैपेसिटी इतना है तो इतने नंबर्स होना चाहिए। कई बार उसमें एक ही डिवाइस को 2 बार लिखा है, मींस इन केस ऑफ वन फेलियर सेकंड शुड ऑपरेट लाइक दिस, तो दैट इज प्रोविजन इन द आईबीआर।
थैंक यू अफजल।
सर बॉयलर इफिशिएंसी कैलकुलेट मतलब कैसे करते हैं?
एफिशिएंसी कैलकुलेशन वो तो पूरा फार्मूला दिया हुआ है भाई, उसमें सारी चीजें हैं। एफिशिएंसी का मतलब है आप कितना हीट दे रहे हो, इनपुट और आउटपुट एफिशिएंसी है, आपका टोटल कितनी आपने एनर्जी दी और कितना एनर्जी आपको मिला, दैट इज एफिशिएंसी। तो दैट इज डिफरेंट, मतलब नंबर, काफी लेंथी कैलकुलेशन है।
On what basis boiler may be scrapped, sir?
Scrap, if suppose boiler is not because जब आप boiler ऑपरेट करोगे तो slowly thickness में भी reduce, corroded, if you want, मतलब उसका जो they have given, actually in the IBR have given a provision कि उसका assessment करना होता है, life assessment, and based the present we can use or not use, so they have given a guideline how to assessment, what are the entities required, and again the samples are required for mechanical tests, number of tests are required. Based on that, if the compliance is not meeting, then that boiler may be scrapped. Already that provision in the IBR in detail.
Thank you, sir.
Yeah, there is Afzal ji. There is one more requirement which is coming in the boiler, which generally as a part of audit people are missing. Whether I'm correct or not, just guide me. That boiler must be checked periodically for their NOx level, whatever the steam which is there, and it is mentioned, but even the user and we also are not aware. Is this correct or?
यूजर को तो सर पता ही होना चाहिए, because
नहीं, वो तो यूजर तो because the person who is there, the competent person, sometimes he is having only that pressure testing gauge, pipeline, and all those things are there. Like the NOx level also to be checked for the steam which is generated, the flue gas which is there in the inside, which is generally not being seen anywhere. So that is how during the audit, when it is being asked, people are not aware of this.
No, I think I can put a light on this.
Yes, sir.
Can I go ahead?
Yes, sir.
Yeah, basically, if you see, always in a factory where the boilers are there are not only one IBR is applicable. There are also environment which is also applicable. Like you are using coal or what kind of fuel you are using. This is always depend upon that. So noise, you are saying the steam when it's blowing up, when the suddenly emergency takes place, then safety valves pop up. All this noise and other thing will be covered under your environment regulation. Even when you are having this coal system, conveyor system and all, that also makes a lot of noise. And that also has to be covered under that one. So that number of this act will be applicable. So the operator has to know all these things. That has to be taken as a separate.
Sir, I was asking NOx level.
Sorry, which level?
NOx.
NOx level. Okay. I know. I think there is a requirement is already given in the IBR regulations. You can go through it. And of late, IBR has also made many changes. So you have to really go through it. You have anything, Afzalji?
हाँ सर, एक्चुअली नॉट अवेयर, बट IBR में जरूर होगा, कहीं ना कहीं काफी डिटेल्स, काफी चेंजेस आर मेड इन द IBR because number of amendments are there.
What about this? The boilers which are used in nuclear power plant for steam generation, does it cover under IBR?
Yes, sir. Basically, all the boilers based on size and pressure, all the boilers comes under the IBR.
And thermit boilers, what are the thermit boilers? What is the size of thermit boiler? It comes under IBR.
Size of a boiler, as per the definition of IBR, if the volume of water is 22.75 liter and more, that is come under the IBR.
Okay.
Not only vessel and the other accessories and fittings and everything.
Afzalji, is water quality as a input of boiler is also controlled through this IBR Act?
Yes, sir.
What parameters should be for this water quality?
Yes, water quality actually should be checked, which is already mentioned in the IBR in the last chapter, last regulation, I think 626 number. It is clearly mentioned the water should be checked and this is the requirement should meet the of the water used for the boilers. तो क्या है, but actually I don't, याद नहीं है, but the provision is already in the regulation.
So during the audit, we can also check this parameter.
Yes, you can
also
demand.
that the water
Yes,
quality is properly controlled by the organization.
Right.
So generally, we miss these things, so we must also see.
Yeah, Mr. Surinder, water again divided into two categories. One is the cooling water, the coolant and all those things, condensers and cooling towers and all this. That water quality is different than the water which is used to steam, which is recycled. Quality has a lot of rigid parameters which is required as to here. So that IBR gives the recommendation kind of documentation. Everything has to be very controlled.
Sir, any significant effect to the environment by the boilers?
That is, sir, light on this.
What is that question?
Significant effect of the boiler on the environment.
There are many.
I think Mr. Anandji can give, there are many things in that. Please go ahead. Apart from that, there is a lot of occupational hazard is there in this boiler plants. So that also has to be taken. Can you put some light, Anandji?
Sir, in boiler, generally, one is the resource usage is there initially when we are using a lot of resources for generating the steams. So what kind of resources are being used for as a fuel? That is one significant aspect directly. Then the other significant aspects are the wastage which is generated while erecting the boiler and while maintenance. There are a lot of wastage being generated, which is categorized sometimes hazardous or sometimes it is recyclable waste. Then it significant aspect comes your leakage of your steams or efficiency of the boiler. In case that efficiency is also not good, that is also a significant aspect in that. And then kind of flue, that steam which is generated, whether it is having the correct appropriate NOx level or not, that also comes into that category. Then it comes your there are some more are there in that that what kind of
you use a lot of can I add, Anandji, please?
Sir, please.
So there are a lot of additives that you use in water treatment because you deal with a lot of water which is potable water. So you use a lot of additives within the water for ensuring that your corrosivity of your material within the boiler tubes, because scaling is a big problem within the boiler tubes, and that's where your efficiency falls. So wherein you use a lot of inhibitors. So those inhibitor contamination, and invariably your I have to yet see one very clean water treatment. So typically they start leaking, you'll see water all over the place. So you have a lot of water issues. Plus another, I think the most significant aspect which we are forgetting is asbestos. You have a lot of insulation within a boiler that you do to increase the efficiency. Correct. And you still use a lot of primitive techniques, like a lot of asbestos is used within the insulation methods. So that is one thing which will also be a big significant as far as the environmental pollution is concerned, and occupational hazard, both.
Correct. And that majorly that design aspect is also is considered as a significant because design is again, it comes all those things covering many areas, pressure, pipeline, how many bends are there, and all those things are there.
And मुझे ऐसा लगता है sir, again this is from the statement जो पीछे चल रहा था कि हम where Surinder said that boiler के साथ हम pipeline को क्यों नहीं करते. I thought we have specific and Kadaria sir added the concept of noise over there. So I think we should, ये मेरा मानना है, could be incorrect. मेरा मानना है कि there are specific standards like noise levels are within the Factories Act. They give you a operability standard as per location. So हम noise उसी standard में पकड़े, ना कि IBR में ढूंढे. हम जब operations देखते हैं तो जैसे हमारा जैसे आप IBR use करो या boiler and pressure vessel ASME में आप ASME boiler and pressure vessel code use करो, चाहे आप within a plant कोई भी equipment which is called a boiler, whether it is a part of any big plant like a steel plant uses boilers, or a chemical plant or a chemical factory uses a boiler. A boiler still is a boiler wherever, irrespective of wherever it is placed. So if it meets the requirements of pressure and 8-inch in terms of wall dia, it will come into the IBR gamut and needs to be controlled, and that kind of awareness is to be there within the auditors who are going and auditing. So if we realize that something is used as a boiler in capacity of a boiler in any capacity within any plant, it will still attract the IPR regulation. उसके साथ का associated piping I don't think इतना लोग करते हैं, because आप boiler inspection जब periodicity में भी करते हो तो आप boiler को, this is my understanding, आप boiler को restrict करके boiler का ही test करते हो, आप पूरे pipeline को जोड़ते नहीं हो, because that pipeline would be running into within your plant into various processes, units, and that steam you would be carrying in many locations. तो उसको हम pressure vessel code करते हैं. Technically, the risk is that if there is a blow off, it is going to be at the first flange of your boiler. It will not go to another line, and unless your line is weak. So वो आप अपने pipeline को monitor करते हो on a periodic level. So everything boils down to if you're doing periodic pressure testing of your lines, whether it is the vessel, which is done once in 3 years or 5 years, or your pipeline, which is also done once in 3 years or 5 years, you're still meeting the risk assessments of both the units. May not be together at a single span, but differently is still being met. And that is way beyond your operating pressure. So आपका operating pressure से आप at least 1.5 times or 2 times आप अपना testing करते हो, तो automatically that risk is mitigated unless you're not monitoring your corrosions, and you have such fast rates of corrosion that your facility or your pipeline or your boiler is getting deteriorated before the next segment. So इसके लिए UT checks का provision है उसमें, where you're doing periodic UT checks, where you're doing visual inspections, and उसमें ये सब निकलना चाहिए. That's it from my side.
Correct, because when we are seeing a product, there are many other standards and requirements are attracting to that. So that all will come because there are multiple statutory and regulatory requirements, standard requirements are there.
So if we have any last minute questions, otherwise we have already surpassed the time, and then we can move to Mansi. So amazingly well covered, Afzal. So beautifully covered the entire segment. Congrats. And over to Mansi. Anand, you wish to add something? Otherwise, we'll hand over to Mansi.
No, sir. Thank you.
Mansi, over to you.
An event like this cannot happen overnight. The wheels start rolling weeks ago. We have been fortunate enough to be backed by a team of very motivated and dedicated colleagues of ICS. On behalf of Sadgun Sangh team, I would like to express my gratitude to all esteemed delegates of the webinar for their presence and contribution, and also to the entire backend team of ICS to make this webinar a great success. Our next session on 16th April 2022 shall be on hazardous waste handling and disposal. This shall be taken up by Mr. Anand Pal Singh. Paryavartan 2022. Paryavartan is an annual virtual exhibition and a conference organized by ICS in association with SJK Foundation. This year, we are going to celebrate Paryavartan from 2nd June to 4th June. Here is our banner for Paryavartan with the theme Only One Earth. During Paryavartan, we'll be having eminent environmentalists from various industries sharing their views and knowledge about sustainable environment. Please do join us during the Paryavartan. ICS is pleased to provide you all its research and development. We have published books for integrated management system covering QMS, EMS, and OSHA, excellence in education management, ISO made easy in Gujarati, Marathi, Telugu, and Hindi. You can contact us or Ms. Sushma Kandalkar for reading of this book. Feedback is of utmost importance for us for improving. Please log in on our website www.sadgunsang.org to give your feedback. You shall also get the updates on upcoming and past seminars on the website. Thank you for being a part of the Sadgun Sangh. I, on behalf of ICS, wish everyone a happy Ram Navami for tomorrow and a happy weekend. Thank you.
Welcome.